Okay, then I'm going to talk about the methods of error detection. So, why do we need error detection? That's because when we transmit data, the data may be lost or changed during transmission. Errors can occur during data transmission due to the following three reasons. The first reason is interference. All types of cable can suffer from electrical interference, which can cause data to be corrupt or even lost. The second reason is problems during packet switching, and packet switching can lead to data loss and even possible to gain data. The last reason is skewing of data. This occurs during parallel data transmission and can cause data corruption if the bits arrive out of synchronization. Checking for error is important since computers are unable to understand text. So, I'm going to introduce three ways that computers use to check error. They are parity checks, checksum, and echo check. Let's go to parity checks. Parity checking is one method used to check whether data has been changed or corrupt following data transmission. This method is based on the number of 1 bits in a byte of data. And in parity check, it will ensure that the total number of 1 bits in a byte is even or odd. So there are two types of parity bits: even parity and odd parity. Let's first talk about the even parity. If we send data with 8 bits, or you can set 1 byte as a unit, then we need to reserve 1 bit for data checking, and that bit is called parity bit. Now, we are using the even parity to check. That means we need to ensure that the total number of 1 bit is in the bytes is even. So for this case, here are 4 1 bits in this bytes, and 4 is an even number. So the parity bits need to be set to be 0. And how about this one? There are 5 1 bits. So what should the parity bits be set to? I think the answer is 1. So that the number of 1 bits turns to 6. And 6 is an even number. Then if we choose to use odd parity, then we need to ensure that the total number of 1 bits in the byte is odd. So what should the parity bits be set to? The answer is 0, since there is already an odd number of 1 bits in the byte. Then, if today I sent this string with odd parity, but there are some error occurs during transmission, so the string is being changed. However, we used the parity checks, so the receiver can identify that the transmission error has occurred. However, what if there are 2 bits being changed? Then the receiver cannot identify the transmission error. But don't worry about this. There's a solution to this problem. The solution is the parity blocks. So in parity block, parity check is done in both horizontal and vertical. So in each byte there is a parity bit, and in the end of the data there is a parity byte. Okay, then let's talk about the next way, checksum. Now I want to use checksum to send a block of data. In this block there are 2 bytes, and the first step of checksum is to add byte 1 and byte 2. Then we can get the sum of byte 1 and byte 2. Okay, the next step is to calculate the complement of sum. And after doing this, we can send the data. Now, we can send a block of data, and this block contains the original data block and a byte of checksum. When the receiver gets the data, how can the receiver check it? The receiver needs to add all the bytes in the block, and the checksum is also needs to add in it. And we can get the sum of this data block. Then calculate the complement of sum. If complemented result is 0, then receiver will assume that there's no error occurs. And let's talk about the last way, is echo check. In echo check, the sender sends test packets to the receiver at beginning. Then receiver copies the test packets and sends it back as an echo to the sender. Then the sender compares the echo with the original test packet. If these 2 are the same, then the sender will indicate that the data was transmitted accurately and completely, so transmission can continue. However, if the 2 are different, then the sender will send the test package again until echo matches the original test packet.